Good morning. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu. I'll respond as soon as I can. All right, so today we're going to go on and cover section 7.4. But before we do that, I did check my email just now, so I've got a request from one of you students. We're going to take a look at some questions from section 7.3, starting with number 29. So here we go. It says, build the following rational expression into an equivalent expression with a given denominator. So the original rational expression is 6 over 7b, and the given new denominator is 21b to the 5th. So basically we need to go from here to here. To do that, I need to multiply the bottom, the 7b, by whatever it takes to make it into 21b to the 5th. Well, 7 times 3 is 21. B times b to the 4th is b to the 5th. So we need to multiply the denominator by 3b to the 4th, which means we also need to multiply the numerator by 3b to the 4th, which means our new numerator is 18b to the 4th. So here's the final answer. Now, for the student who asked about this question, I noticed that what you had was this. So I wonder if you either forgot what you were doing or maybe got your answer and then reduced it and went right back to where you started from. But they wanted the built up equivalent expression. Okay, we okay with that one before we go on?
Yes, thank you.
All right, let's take a look at problem 32 coming at you. Let's see here, hang on, move that over here. So 7.3, number 32, build the following rational expression into an equivalent expression with a given denominator. All right, and we've got, let's see, x plus 7 over 3x minus 15. And we want the new denominator to be 3 times x minus 5 times x plus 13. So basically, I'm going to recopy the original fraction, only I'm going to factor the denominator completely. Okay, so now we've got, let's see, this is our new denominator. So we want this to look like that. What are we missing? Whoops, hang on here. That's not what I wanted. I gotta make it go. No. Sorry, I accidentally bumped into things and messed up the picture. Okay, hopefully that's right. So what do I need? I need, well, I've got a 3, I've got an x minus 5, and an x plus 13. X plus 13. So up here I need an x plus 13. So my new numerator is going to be x squared plus 7x plus 13x plus 91. So ultimately, I'm going to have x squared plus 20x plus 91 over 3 times x minus 5 times x plus 13. So there is that. Any questions about that one? Oops. How about like, where did it go? There it is. Sorry about that. Okay, we good? I'll take that as a yes.
Yes, thank you.
And we're going to go on to number 33. Basically the same idea. We've got y plus 5 over y squared minus 13y plus 40 And our new denominator is to be 6y, y minus 8, y minus 5. Okay, let's see if I can make enough room this time. So y plus 5 over y minus 8 minus 5 equals something over 6y times y minus 8 times y minus 5. So what am I missing over here? 6y. So what do I need up here? 6y. So what's my new numerator? 6y squared plus 30y. So there's my final answer. Any questions on that one?
No, I'm good. Thank you.
All right, and finally, 7.3, number 34. Again, same idea. We've got 13 minus h over h squared minus 9. Oops. And we want it to have this denominator 2 times h plus 3, h minus 3. So 13 minus h, and then h squared minus 9 is h plus 3, h minus 3. So all we're missing over here is a 2, which means we need a 2 on top, and we get what, 26 minus 2h. And there's our final answer. All righty. Any other questions about yesterday's homework before we go on? Now is the time if you have any questions you want to look at. Okay, we'll go on to section 7.4 then.
Actually, can you do number 20 or 45?
45, okay. 40,
Sorry.
that's okay. Fortunately, I hadn't closed it up yet. Okay, 7.3, number 45. What is the difference of the length and width of the rectangle?
We just need to.
Difference of the length and the width. Okay, so I'm going to show the picture here. If I can find my mouse. Where are you? There you are. Okay. All right, so let's see, we'll move that up there. We've got this rectangle. And the length is 5x plus 11 over x plus 2 feet. And the width is 3x plus 5 over x plus 2 feet. And it's asking us to find the difference in of the length and the width. Okay, so I'm assuming that they're going to use that as the length and that as the width. So basically, we've got a subtraction problem. We're going to take 5x plus 11 over x plus 2 minus the quantity 3x plus 5 over x plus 2. Recall that when we're subtracting a quantity, we need to either parenthesize the quantity or distribute the subtraction to start with. I'm going to parenthesize it. I don't know if that's a word, parenthesize. So we initially get that. Then distributing the subtraction, we get 5x plus 11 minus 3x minus 5 over x plus 2. Combining like terms, we get 2x plus 6 over x plus 2. Now, we could factor a 2 out of the numerator, but it doesn't get us anywhere. So we'll go back to this and make this units of feet. So 2x plus 6 divided by x plus 2 feet. Anything else before we go on? Speak now or forever hold your peace.
No, I'm good. Thank you.
Okay. Anybody else? All right, we're going to go on to 7.4. Here we go. So in 7.4, well, let me back up a little bit. What have we done? We've looked at adding and subtracting fractions with the same denominator. And then we worked on finding the least common denominator when they didn't already have the same denominator. So today we're going to look at adding and subtracting fractions that initially have unlike denominators. We'll have to find the common denominator, build each fraction, blah, 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 blah. Okay, so what I want to do is I want to go back to some basic arithmetic ideas. So hang on there, get things organized. Okay, I want to move this over just a little. Maybe. It's not, there we go. Okay. Let's say we have 1/2 plus x over 3 equals 2/5. Okay. So we have an equation containing fractions. The first thing we're going to do is clear out all the fractions by multiplying both sides of the equation by the least common denominator. So actually the first step is to find the LCD. Can anybody tell me what it is?
6.
No. Look again. Anybody? Don't forget that 5 over there on the right side.
Would it just
30?
be 1?
Would it be what?
1?
No.
30.
There you go. 30. It's the product of the highest power of each prime factor. So 1, 2 times 1, 3 times 1, 5 is 30. We okay with that? Any questions there? All right. So now we're going to take both sides of the equation and multiply by 30. So we're going to have 30 times 1/2 plus 30 times x over 3 equals 30 times 2/5. So we found the least common denominator. We multiplied both sides of the equation by the least common denominator. And when I go through and simplify things, we'll get rid of all the denominators. So 30 times 1/2, 30 over 2 reduced down to 15 over 1. So I have 15. 30 times x over 3 reduced down to 10 over 3, 10x. So 10 over 1, 10 times x is 10x. 30 over 5 is 6. 6 times 2 is 12. So is everybody okay with how I got rid of the fractions? Okay. If you want to look at more of this in a simpler form, this is actually from chapter 2. Let's see, what is it? 2 point, hang on. 2 point. .2, I think it is. Yeah, section 2.2 back in Math 85 would have covered this, but we're going to take it to the next step here in just a minute. All right, so now I'm going to subtract 15. So 10x equals -3, divide by 10x equals -3/10. Okay? Any questions? Now, what were the steps? We had an equation containing fractions. We looked at all the denominators. We found the least common denominator. We multiplied both sides of the equation by the least common denominator. That is to say, we distributed it to each term on both sides of the equal sign. We went through and reduced each fraction or each product, which gave us an equation without any fractions. Then we isolated the variable term and then isolated the variable to get down to our final answer. Okay, so here we go. Let's take a look at this problem. Y divided by 4 plus 3y divided by 5. Oh, you know what? My bad, my bad. Oh. I don't know what I was thinking. I jumped ahead. I jumped ahead to solving equations instead of just, yeah, my bad. So basically everything I just did, all of that, this example right here, it's coming later. I don't know what I was thinking. Somehow doing this problem just triggered something. It's coming later. Okay, so let's just erase the last 50 or 10 minutes of explanation until later. So sorry. I'm having a Monday. All right. Now, we have two fractions. To add them, we need to find a common denominator. We'd like to find the least common denominator. What is the least common denominator of 4 and 5? Anybody?
20.
20, right. Okay. I am so sorry. So now we're going to take each original fraction and rewrite it as a new fraction with the new least common denominator. We just looked at about 4 or 5 examples of that very thing from the web assignment from yesterday. Okay. So how do I get from y over 4 to something over 20? What do I need to multiply the 4 by to get 20? How about a 5? 5 times 4 is 20. So I multiply the numerator of that fraction by 5 and I get 5y. So basically y divided by 4 is equivalent to 5y divided by 20. Okay? All right. Now, 3y over 5. I'm going to multiply that by 4 in the denominator to make it a 20. So 4 in the numerator to make it 12y. So now I am adding two fractions with the same denominator. 5y plus 12y is 17y over 20. I can't reduce that, so we are done.
I have a question on this one.
Yes.
So like the last one we just did it by, oh, sorry. We did it by 20. So wouldn't we take y over 4 times 20 and then you would get just
Okay,
5y?
Okay. Again, my apology. Forget all of that. That's when you have an equation. I jumped the gun. I got ahead of myself about 2 days worth there for whatever reason. So in this problem here, we have an equation and we're clearing the fractions. We're not there yet. That's actually that's actually 7.6. Okay, it's coming. So here, and it was 30. Here we multiplied to clear the fractions. Here we're building to get to the least common denominator. Okay. You all right, Lindsay?
Yeah, thank you.
Yeah, sorry. So again, now that's the problem because I led you astray. Now I've got to reel you back in. Okay, another example. Maybe I should have just done 7.6 today. Apparently I thought I was going to. I don't know. All right, take a look at this one. 6 over n squared minus 2 over n. What is the least common denominator?
N squared.
N squared. If it ain't broke, don't fix it. So the first fraction already has the least common denominator. What do I need to multiply the denominator of the second fraction's denominator by to make it into n squared?
One n.
Right. So I multiply the numerator by 1n as well, and my new numerator becomes 2n. So now I'm subtracting two fractions with the same denominator. I get 6 minus 2n over n squared. Now, I can factor a 2 out of the numerator, but it doesn't simplify further. Therefore, we'll just go back to this. Okay. So again, we're not dealing with equations yet. That comes in a couple of days. We all right with this one? I'll take that as a yes. Okay. 3 over 10a minus 13 over 15a cubed. What's the least common denominator? Careful. Let's look at the numbers first. What's the least common denominator of 10 and 15? Well, let's see. 10 and 15. 10 is 2 times 5. 15 is 3 times 5. So I need a 2, a 3, and a 5. And then the largest power of a there would be a cubed. So it's going to be what? 30a cubed. Are we okay with how I got that? All right. What do I need to multiply 10a by to make it into 30a cubed? What do I need to multiply 10 by to make it into 30?
3.
3. How do I change a into a cubed? I need to multiply by a what? Just a?
Squared.
Squared, right. So if I multiply the denominator by 3a squared, I have 30a cubed, which means I need to multiply the numerator by 3a squared. 3a squared times 3 is 9a squared. So I've taken 3 over 10a and built it up to 9a squared over 30a cubed. Okay. So I took a fraction and wrote it as an equivalent fraction with the LCD. Everybody see what's going on here? Okay. How about over here? What do I need to get from 15a cubed to 30a cubed?
2.
What's 2 times 13?
26.
All right. So now I've got 9a squared minus 26 over 30a cubed. I can't do anything to, I can't factor the numerator, so that's my final answer. It's not gonna simplify any further. All right. We good? I guess. Okay. 5 over p squared minus 9 plus 2 over p, 3p plus 9. All right, well, now things are a little bit trickier. Let's see. I'm going to factor each denominator. This is p plus 3, p minus 3. This is 3 times p plus 3. So my LCD, I need a 3, I need a p plus 3, and I need a p minus 3. Any question where I got those 3 factors as the LCD? Okay. What do I need right here to make that denominator the same as the one down below? What's missing?
Just multiply it by 3.
So what do I do to the numerator? Same thing.
15.
Okay. Again, everybody see what's going on there? What about over here? What's missing?
P minus 3.
So what goes up here? P minus 3. So I get 2p minus 6. So now I've got 2p minus 6 plus 15 over the LCD. which is 2p plus 9 over 3 times p plus 3 times p minus 3. And I just wrote that because I wasn't going to do anything with it until the next step because I still had to combine like terms. Okay. So 2p plus 9 over 3 times p plus 3 times p minus 3. Everybody still okay? Still got a pulse? Still alive? All right. We're going on to another one. Let's see here. 4 divided by s squared plus 5s plus 4 plus s divided by s squared plus 2s plus 1. So I'm going to factor each denominator so I can figure out what the least common denominator is. Okay. So s squared plus 5s plus 4 is s plus 4 times s plus 1. Okay. S squared plus 2s plus 1 is s plus 1 times s plus 1. Or I could write it as s plus 1, the quantity squared. Okay. So what's my LCD going to be? Well, I'm going to have an s plus 4 times an s plus 1 to the second power, because that's the highest power of that factor within either of the different denominators. Okay. So down here, what do I need? I need a denominator of s plus 4 times s plus 1 times s plus 1 plus s plus 4 times s plus 1 times s plus 1. What am I missing in that first denominator to make it look like the denominator down below? What do I need?
S plus 1.
Yeah. So my numerator, s plus 1. So I'm going to get what? 4s plus 4. Okay. Everybody see that? You're looking here and going, oh, I've got that. Let's see. I've got that. I've got that. Oh, this is the one right here I'm missing. I need one of those. Okay. How about over here? What am I missing there?
S plus 4.
So in the numerator, I need an s plus 4. So distributing, I get s squared plus 4s. Okay. So what have I done? I had two fractions I'm trying to add. They don't have the same denominator. I factored each denominator so that I could build the LCD by using the highest power of each factor and multiplying them together. Once I found the LCD, I wrote that down below. That's the new denominators I need to get to. What did it take to multiply the first fraction on top and bottom to make this the new fraction? Now that I've got two fractions with the same denominator, I can add the numerators. 4s plus 4 plus s squared plus 4s all over the LCD. S squared plus 8s plus 4 all over the LCD. Let's see, s squared plus 8s plus 4. That doesn't factor. So in fact, my final, well, actually, let's just do this. Let's go back here. And this is going to be what? S plus 4, s plus 1 squared. Okay. Or you could write it as s plus 4 times s plus 1 times s plus 1 if you wanted to. Any questions on this one? All right, we'll keep going then. Let's see here. 5 divided by x squared minus 9x plus 8 minus 3 divided by x squared minus 6x minus 16. So I'm going to factor each denominator. 5 over x and x, let's see, minus 8x minus 1. Okay. Minus 3 over x minus 8 plus 2. Yeah. Now, I did this a little bit differently. Last one, I just took the original fractions and just factored the denominator. Here, I not only did that, but I recopied the numerator. Okay, same idea. What's my LCD? I've got x minus 8s, x minus 1s, and x plus 2s. How many of each of them do I need? 1. All right, because the highest power of anyone, these are all to the 1 power. Any questions there? Okay. What's missing that goes below the red line so that I have the same denominator as down below? What's missing?
X plus 2.
Yeah, this is just an eye exam, folks. That's there, that's there, that's there. Oh, x plus 2. Okay. So I need an x plus 2 on top, which means I need a 5x plus 10 as my new numerator. Can you say new numerator? You can, but you don't want to, right? Okay, how about over here? What's missing?
X minus 1.
Hey, I'm all alone here in my basement. I have to do something to keep myself amused. All right, so the new numerator is x minus 1. And I'm going to get what? 3x minus 3. Okay. Now be careful. We're subtracting a quantity. So now I'm going to get 5x plus 10 minus the quantity 3x minus 3 all over the LCD, which is 5x plus 10 minus 3x, minus times minus is plus 3 all over the LCD. Combining like terms, 2x plus 13. I don't think that's going anywhere, so I'll go ahead and write out the LCD. And when I say it's not going anywhere, you can't do anything to factor 2x plus 13. Again, any questions? All righty, going on. 9n over m plus 4 plus n. So what's the implied denominator of the second term? What's under the n?
1.
Correct. Okay. So now my denominators are m plus 4 and 1. What's the least common denominator of m plus 4 and 1?
M plus 4.
Correct. So the first fractions, okie dokies, don't need to do anything to it. The second fraction, I'm going to have to multiply the denominator by m plus 4, which means I'm going to multiply the numerator by m plus 4, which means my new numerator down here is going to be mn plus 4n. I'm telling you, those of you that have a hard time waking up in the morning, you don't need coffee, just do a couple of these, your brain will be engaged. All right. So now what have I got? I've got 9n plus mn plus 4n over the LCD. Combining like terms, I've got 13n plus mn over the LCD. I can factor out an n and get 13 plus m over m plus 4. But that doesn't get me anywhere. So I'm going to go back here and just stay with that. All righty. More fun coming up. 4 over b minus 6 plus b over 6 minus b. Now, at first glance, you might say, oh, the LCD is b minus 6 times 6 minus b. And you take the first fraction and multiply it by 6 minus b over 6 minus b, and the second fraction times b minus 6 over b minus 6, and you get a big mess that you don't need. These two denominators are opposites of each other, aren't they? Think back to the earlier on when we were factoring and we had something like, b minus 6 over 6 minus b was -1 because it was a number divided by its opposite. So if these numbers are opposites, what if I came in here and took the second one? I could have done it to the first one, but the first one, b minus 6, that's kind of in standard form as opposed to 6 minus b. So I'm going to leave the first one alone, and I'm going to mess with the second one by multiplying by -1 over -1. So now I have that as my first fraction. And let's see, what's that going to be? Well, what's 6 minus b times -1? That's -6 plus b, which is b minus 6. So you see that by taking the second fraction and multiplying by -1 over -1, I turned the denominator into the same denominator as the first fraction was. That's a little nicer than what I first proposed there, isn't it? So now I've got 4 minus b over b minus 6, and we're done with that one. Any questions there? How did I know what to do? Because these are opposites. So taking that to the top and the bottom turns this into that. Okay. Let's do another one of those. H over h squared minus 49 plus 7 over, over 49 minus h squared. Same idea. The two denominators are opposites of each other. So let's take the second one and multiply it by -1 over -1. So now I get h over h squared minus 49 plus -7 over -49 plus h squared, which is h squared minus 49. So then I get h minus 7 over h squared minus 49. However, with this problem, we can take the denominator and factor it and reduce it down. That doesn't always happen, but in this case it did. After we combine the two fractions, we got a new fraction that would reduce. Any questions? How about, let's see here. This one. 5/9x plus 4/x plus 6. What's the LCD? Careful. Anybody?
Is it 9 and x plus 6?
Okay, why didn't you include that? Because it was over here?
Yeah, that's wrong, huh?
Yeah,
it's the
because
wrong
this is not a
equation.
factor, is it? Yeah, that's that tricky situation we've got to be careful of. This is like 3 times 3 times x, but this is just x plus 6 as a factor. So I've got to take 3 squared times x plus 6. Because this x is not a factor, okay? So my LCD is 9 times x plus 6. What do I need here in the denominator? Below the red line. X plus 6, right? Because then it looks like the one down here. So I need what? X plus 6 on top. And I've got what? 5x plus 30. Okay. What do I need down here? A 9x. So I've got 36x. Are you getting this, folks? Are you seeing what's going on there?
Yeah, I see it.
Okay, okay. You see it, you just don't know whether you want to believe it or not. Okay. All right, so now what have I got? I've got 5x plus 30 plus 36x over the LCD, combining like terms, 41x plus 30. 41x plus 30 isn't going to factor, so I'll go ahead and write the denominator, and that should be my final answer. Okay.
So on this one, we don't multiply the denominator out.
You can. It's kind of weird. Sometimes they will, sometimes they don't. Typically, they multiply the numerator out and then leave the denominator factored, but it should be acceptable to do it either way. So like if you wrote, 41x plus 30 over 9x squared plus 54x, that is equally correct. Ultimately, the form you leave it in depends on what you're going to do with it next. So like if we were going to take this answer and do something else with it, that would dictate whether to leave it factored or multiply it out. But since this is the end of the problem, it's like, it doesn't matter either way, okay? Now, having said that, let's go back for a minute and look at why did I have to multiply that together? Why didn't I leave that as 5 times x plus 6? Why did I multiply it out? Because I was adding 2 fractions. I was going to be adding those numerators, so I needed things simplified. But since my denominator was common at that point, I didn't need to do anything to it further. Does that make any sense?
Yeah, because if you leave it like that at the end of the problem, when you go to simplify and you cross stuff out, you don't get the right answer if you don't multiply it out.
Good point. Good point. Okay. One last example here. These are called lookalikes. Recall from basic arithmetic. When you're adding or subtracting fractions, you need a common denominator. When you're multiplying or dividing fractions, you don't need a common denominator, and finding one is a waste of time. So this first one, our LCD is 30x. So we're going to multiply by 15 over 15 and get 75. by 2x over 2x and get 8x squared. And our final answer is going to be 75 plus 8x squared over 30x. Okay. The second one, we can go in and just reduce it and get 2/3. All righty. So it's typically easier to multiply and divide than it is to add and subtract, at least when we're dealing with fractions. All right, that's all I have for you today. So I will be back at 1:15 with an office hour should you have need of me. Otherwise, I will be back tomorrow at 11:30.